Let's do more examples. Let's find the absolute maximum and minimum values of different functions, starting with f of x equals x to the 2/3 on the interval -8 to 27 closed interval. Okay, here we have a continuous function x to the 2/3 on the interval that is closed. So the extreme value theorem says that there will be an absolute maximum and an absolute minimum. So let's find the critical points first. Take the first derivative, 2/3 x to the -1/3. Okay. Is it equal to 0 for any point? No. Never equal to 0. So that means there are no points where the tangent is horizontal. But does this mean that there are no critical points? Also no. The critical numbers are the points where f prime is 0 or is not defined. So x equals 0 is a critical number because f prime of 0 is not defined, does not exist. Okay, you see here the derivative has x to the -1/3. So that is a limit that does not exist as x approaches 0. Okay. Now, the extreme value theorem says that we need to check x equals 0, -8, and 27, the critical numbers and the endpoints. So f of -8, that is -8 to the 2/3, right? Remember, when we write 2/3, actually this is like a cubic root and then a squared, okay? And the cubic root, it's an odd function, so we can take a cubic root of a negative number. So this is -2 to the power 3, right? That's -8. Then to the 1/3, so that is -2, right? To the power 2, and that makes 4. F of 0, this one is easy. This is 0 to the 2/3, which is 0. And then f of 27, which is 27 to the power 2/3, right? But this is, again, this is the cubic root of 27 to the power 2. But 27 is 3 times 3, 9 times 3, right? So this is 3 to the power 3. The cubic root is 3. So this is 9. And now looking at the values, we have that 0 is the smallest and 9 is the largest. So we have an absolute minimum at x equals 0 and an absolute maximum at x equals 27. Okay. Let's do one more example. Let's do something more complicated now. Let's take 2 sine of x plus cosine square of x, something that we cannot guess easily. And let's work on the interval 0 to pi. Again, because this is a sum of two standard functions, right? 2 sine of x and then the cosine square of x. And the interval is a closed interval. We have a continuous function over a closed interval. So we will be good according to the extreme value theorem. Let's compute the critical numbers. The derivative, 2 cosine of x plus, here the chain rule, 2 cosine of x times negative sine of x. and we want to make f prime of x equal 0. So that means 2 cosine of x equals 2 cosine of x sine of x. Okay. So there are two possibilities here. Possibility number one, you may be tempted to just cross the cosine, but you should be careful doing that, okay? Because we need to make sure that the cosine is not 0 if we are going to do that, okay? If the cosine is not 0, then I can just, let me copy it again so that I can cross freely. In that case, sine of x must be equal to 1, okay? And when does this happen? The sine is equal to 1 when x is pi over 2 plus 2 pi k. All right. And then the second possibility that we were saying, well, is that the cosine of x is actually 0. In that case, we are good, because if you notice, the 2 cosine of x equals 2 cosine of x sine of x. Now this is totally true, because both sides are 0. Okay, so in that case, there is nothing we need to do. We just need to figure out what are the values for which the cosine of x is 0. Okay, and the values for which the cosine of x is 0 are this one here and this one here. Okay, so we have pi over 2 and 3 pi over 2. And then we have the 2 pi k and so on. Okay, but here, let's be smart. Okay, because remember, we are being told that we need to look for extrema in the interval 0 to pi. Okay, so in the interval 0 to pi, we are going to do just one term. So we can forget about the 2 pi k, because we are working on 0 to pi. So easier for us. If you notice here, there is also repetition, right? The pi over 2 appeared twice, no problem. That's just the pi over 2. Okay, so we have here the points to check are 0, because it's an endpoint, pi over 2, and 3 pi over 2. And then the other endpoint, 2 pi. Okay, so in this case, we just need to check the values f of 0, f of pi over 2, f of 3 pi over 2, and f of 2 pi. And then the values here, because we have our function, which is 2 sine of x cosine squared. When we plug in the values, the sine of 0 is 0, so the cosine squared is 1. At pi over 2, we will be looking at this point here, right? At pi over 2, the sine is equal to 1, and the cosine is 0, so that's 2. 3 pi over 2, it's the opposite, okay? At this point, the sine is negative 1, and the cosine is 0, so this is negative 2. And then f of 2 pi, in this case, the sine of 2 pi is equal to 0, and the cosine is equal to 1. Okay, so looking at these values, we have the absolute maximum, which is 2, and it's attained at x equals pi over 2, and the absolute minimum at x equals 3 pi over 2.